Alright, so this lesson is 7.3, and this takes and pulls all your sequences together. Some are real familiar, some are new. Okay, so let's take a look. First thing we talked about already is compound interest, right? Which is interest calculated on both the principal and any previously earned interest. So it's almost like if you start with $1,000, right? That's your starting balance. If you earn $10 in interest, now your new balance would be your interest, right? But then you earn more interest, so now you're earning interest on that amount, right? So it would be plus 15, blah, blah, blah. So when you look at it, it's interest that's calculated on the principal and the interest earned. Fibonacci sequence is the new one, and we're going to talk about this a little bit more, but it's a sequence of numbers that starts with the number 1, and for which each subsequent number is the sum of the previous ones. Okay, so we'll talk about that a little more via example. Which the Fibonacci sequence is also basically a pyramidal of numbers, which is a sequence of numbers that are the sum of the perfect squares. So you would have 1, then you'd have 1 plus 4, which is 5, and you'd have 1 plus 4 plus 9, which is 14, and so on. Alright. Now, simple interest is interest only paid on the principal balance, right? And that is it. Now, simple interest is related to your arithmetic sequence, right? And if we go up to here, compound interest is related to your geometric, right, sequence. Okay? So let's take a look here. If we look at the chart here, just a quick review. In explicit for an arithmetic sequence, a sub n is the value of the nth term, right? A sub 1 is the first term in the sequence, n is any term in the sequence, and d, remember, in arithmetic has a common difference. Okay? Now, when we talk about the explicit formula for a simple interest sequence, right, a sub n is the amount, right, in the account after interest is applied n times. P is your starting amount, which is also known as your principal. N is a number of times interest, right, is applied. And I is the interest, right, rate written as a decimal, right? So when we look here, right, P is your starting amount. I is your interest rate. And N is basically your number of times interest is applied. Okay? And then A sub N is the amount after interest is applied. So let's take a look at a few examples here. It says here, a cyclist is riding from the city to the country. She rides 20 miles each hour. At the beginning of the first hour, she's at 10 miles away from the city center. At the beginning of the second hour, she is 30 miles away from the city center. Write an explicit formula to show her distance from the city at any given hour. Alright? Then use the formula to begin her distance at the beginning of the fifth hour. Now, what type of sequence is this? Right? Well, when I look at it, it's an arithmetic sequence, and right away, what is your starting amount? Her A sub 1, how far is she away from the city? 10 miles. Now, what is her rate at which she's riding? She is riding at 20 miles each hour, which means her rate, right, or that common difference, right, is 20. And if you remember, in an explicit rule for in arithmetic, it's A sub n equals your initial amount plus your rate times n minus 1. So, in this case, A sub n equals 10 plus, what is your rate? 20 miles per hour times n minus 1. So now the nice part about this is we are able to use that to find how far she is in the fifth hour. So we're going to let n equal 5. So A sub 5 is equal to 10 plus 20 times 5 minus 1. So A sub 5 is equal to 10 plus 20 times 4. And right away, 20 times 4 is 80 plus 10, which is 90 miles away. All right, she's 90 miles away from the center of the city. Now the next one, right, next to it, on your 16th birthday, you open a savings account, all right, with $1,000. So right away, your initial amount, right, so when you go up here for simple interest, right, that's your P. So remember, A sub 1 is now P, which is $1,000. The account pays 4%, so right away your rate is 4%, but as a decimal, I'm going to take 4 divided by 100, or know that it's 0.04. How much will it be in the account on your 50th birthday? So we say A sub n equals your initial amount, right? And if I go up to the formula here, right, it's your principal plus your interest rate times P, right, and then times n minus 1. So what is my principal times my rate? So right away my principal is 1,000 times my rate is 0.04, okay? And what does that give me? It gives me 40. So it's going to be 1,000 plus 40 times n minus 1. Okay, so remember this rate, you're adding $40 each year. Okay, so now A sub n, the amount in the account after 35 years, we'll go 35, is 1,000 plus 40 times 35. And if I evaluate this, it'd be 1,000 plus 1,360, which would give you there's $2,360 in the account when you are 50. Okay, remember it's 35 years right after your 16th birthday. All right, so get this now. Explicit rule for a geometric sequence, right? A sub n is the value after the nth term again. A sub 1, right, is your first term, okay? N is any term in the sequence, and now R is your common ratio, okay? But now our compound interest formula is a little bit different here, okay? Our compound interest formula, A sub n, is the amount in the account in the nth year. P is your starting amount, or again, your principal. N represents the year, okay, and I represents your interest rate, right? But you remember, you have to convert it to a decimal. Oh, sorry, let me hold that up there for a little bit more. Pause it and write it down. So now, the first one, a bacteria cell reproduces by splitting in half. Write an explicit formula that can be used to find the number of bacteria cells after each generation. Then use the formula to find how many cells there are after 10 generations. So we know A sub n equals, right? How many are you starting with, right? Do I know that? So here it doesn't say in there, so we know we're starting with 1. Now, if a cell reproduces by splitting in half, right? What that means is the rate is it's doubling each time. So my formula would be A sub n equals my initial value 1 times my rate to the n minus 1 power. So when I go to find how many in the 10th generation, A sub 10 equals 1 times 2 to the 10 minus 1 power, right? Which is going to give me 1 times 2 to the 9th, and 1 times 2 to the 9th would give you 512 cells after 10 years. Okay? Now the next one. On your 16th birthday, you open a savings account with $1,000, right? So right away your principal or your initial amount is $1,000. The account pays 4%. So our rate is 4%, but that's 0.04. Now with this, okay, our formula is going to be A sub n equals my principal times 1 plus my rate as a decimal to the n minus 1 power. Now what you're going to see is how fast it grows when it compounds versus simple. So A sub now on the 35th year in the account, 1,000 times 1.04 to the 35 minus 1, which gives you 1,000 times 1.04 to the 34th power. So now, if you look at this, on the 35th year, when you evaluate this in your calculator, you would have $3,794.32 in your account. Okay, if you look, simple interest was the same problem, only gave you $2,360. All right. So now, next, if I look at this, right, a pyramidal sequence, right, is the sum of a perfect square and all of the perfect squares before it, right? So we'd go 1, and this would be 1 plus 2 squared, which would give me 5. This is 1 plus 4, right, plus, so this would be 1 plus 4 plus 9, right, which is going to give me 14. Then when I add 16, it gives me 30. So this one is going to be 30 plus, now I'm going to do 5 squared, which is 25, which will give me 55, and so on. All right. Now, if you look at the Fibonacci sequence, right, in this one, each term in the sequence is the, right, is the sum of the two terms before it, right? So when I look here, you have 1, all right, then 1, then 1, 1 gives me 2, right? The next one would be 1 and 2 give me 3, right? Now 2 and 3 would give me what? 5. Now 3 and 5 would give me 8. 5 and 8 would give me 13. So how do we find this number? 8 and 13 give me 21. Okay? So when we look at a Fibonacci sequence, right, the formula is very intimidating looking, but the explicit formula, P sub n, is the value of the nth term in the pyramidal sequence. So P sub n is the value of the nth term. All right. So we have the explicit rule here, you have the recursive rule here, and now the that's for the pyramidal sequence, and this is the Fibonacci. So we know that f of n is the value of the nth term in the Fibonacci sequence, and f of n minus 1, right, represents the value of the previous term, and f sub n minus 2 is the value of the term 2 terms, right, before the nth term. Okay, so a grocer stacks cans in a square pyramid with 10 layers. The number of cans in each layer makes a pyramidal sequence. How many cans are there in the pyramid? So right now there are 10 layers. So we know n is equal to 10. And we know the formula for this is P sub n equals n times n plus 1 times n plus, plus 2n plus 1, right? And you have to memorize this or have it in your notes, all divided by 6. So all we have to do to figure out the number of cans in each layer is I'm going to replace n with 10 times 10 plus 1 times 2 times 10 plus 1, all divided by 6. So what is 10 times 11 times 21, right? All divided by 6 going to give you? There would be, and go ahead and check this in your calculator and you should get 385. Multiply all the numerators together and then divide by 6. Now the next one says the 14th term in a Fibonacci sequence is 233. The 15th term is 377. What is the 16th term? Remember, in a Fibonacci sequence, right, the next term is the sum of the two previous terms. So if I'm looking for the 16th term, I need to know what was the 14th term, and then I need to know what the 15th term is going to be. Well, what was the 14th term? 233. What was the 15th term? 377. And when I add these together, right, the 16th term would be 610. Okay?